Hi everyone, and welcome to today's webinar. It's great to see so many people joining today to talk about test parameterization. If you're new to this method, today we'll show you how test parameterization helps reduce the need to write repetitive tests, which ultimately makes testing more efficient and maintainable. So let's get started. I'm Tony Salvatoccia, Product Marketing Manager at Xray, and today I'm joined by Ivan Filippo, Solution Architect. Keep in mind that during the presentation, you can ask questions in the Q&A panel, and at the end, we'll have 50 minutes of Q&A where we'll try to answer as many of your questions as possible. So let's see what we have on the agenda for today. First, we're going to explore why test parameterization is important. So when testing applications, and especially large systems, teams often face the challenge of managing many test scenarios. And these tests can become repetitive, taking up valuable time and your resources. With test parameterization, we can efficiently run the same test logic with different inputs and significantly reduce the complexity and duplication of test cases. So in essence, test parameterization improves your ability to scale testing without adding unnecessary overhead. So what we'll cover in today's webinar is a closer look at what test parameterization is, and why it's a game changer for QA teams. Next, we'll focus on how to use Xray for test parameterization. And we'll also touch on how you can optimize your parameterized tests by using the test case designer, which is a feature from Xray Enterprise. Finally, we'll wrap up with some key takeaways and tips on how you can leverage test parameterization to elevate your testing strategy. So with that in mind, let's get started by getting a better understanding of test parameterization itself. I'll pass the word over to Ivan.
Thanks, Tony. Starting from a more strategic level, we are going to briefly talk about data-driven testing, or DDT. It is a software testing technique with several stages, including parameterization, execution, and reporting. Without that technique, if you have a workflow with dynamic but repetitive elements, like a cart checkout, you need to manually create each iteration as a separate test case. From the quality standpoint, that approach often results in a very fragmented view of the system and struggles with redundancies or omissions, which significantly increases the defect risk in production. From the speed standpoint, manual, isolated creation and maintenance cannot keep up with the modern market demands. With DDT, only one test entity is needed with a data table attached to it. Then you will be able to run your test multiple times for each entry in such table. Today, we focus on the parameterization stage specifically. It consists of two parts: inserting parameters in the script and forming the data table. This stage belongs more to the test design realm and prioritizes the theoretical aspects of risks and necessary data coverage. That doesn't mean you can completely ignore the execution restrictions, though. As a quick example here, an authentication test could have been written 3 times separately with different usernames, passwords, and resulting messages. Instead, dynamic elements are replaced with the parameter syntax, while the combinations are moved to the dataset. The fact that parameterization approach allows you to separate scripts from underlying data unlocks more efficiency, accuracy, and scalability. You don't need to replicate the script changes from test to test. You can more easily add or remove scenarios at the dataset level, and all that lowers the chances of outdated or erroneous tests being executed. With that said, it is also important to consider the challenges of parameterized tests. Most of them stem from other DDT stages. Namely, you have to consider execution and reporting limitations while you are designing the script and the dataset. Is the single set of steps truly clear enough to execute all iterations? Can we treat anything dynamic as a parameter, or should we stay away from things like operating system or environment? How can we accurately show the effort to our stakeholders if, on the surface, there is only one test entity? Those are some of the questions you have to discuss before committing to this technique. Next, selective re-execution is a little bit trickier. For instance, when you want to repeat only the failed iterations. It is helpful if your execution tool can handle the scope identification by the row ID of the data source. Another possible solution could be to temporarily subset the data source and reassign it. Lastly, while maintenance is overall more efficient, it does take a bit of a learning curve to avoid desynchronization between the script and the dataset. So how do we make parameterization happen in Xray? First, let's talk about the script editing. Parameter syntax can be added in these different spots throughout the script, providing the flexibility needed for more complex and conditional flows. Parameter names are case sensitive, have a maximum of 64 characters, must start with a letter or underscore, and have certain other restrictions that you can check in the documentation. While you can insert parameters into individual tests directly, there is also a more reusable approach. It is highlighted in levels 2 and 3 on this slide. The menu option in Xray settings is called Parameter Value Lists. The choice between project and global levels depends on your configuration and preferences. If you have, for instance, only one dedicated testing project, sticking to its settings makes sense. If you have multiple testing projects that work with related scopes, global settings for the common reusable parameters will save you more time and improve consistency. Now this second part. As we discussed, datasets store all the iterations to feed the parameters. Xray allows you to create datasets in 3 ways: manual specification, combinatorial generation, and import. Seeding parameters correspond to the first method. They allow you to pick each value independently and build the scenarios however you would like. On the other hand, marking parameters as combinatorial tells Xray to generate all possible interactions for you. It is always possible to convert back and forth between parameter types, and you can have a mix of them in the same dataset. Regardless of the creation method, you can apply adjustments like changing cell values, adding or removing rows, etc. at any point. And last but not least, you need to keep these capacity limitations in mind. One more important aspect before jumping into the demo. The Xray hierarchy of processing datasets. In short, the closer you are to the execution layer, the higher the dataset priority is. Leveraging multiple layers at the same time is not very common, but keeping this logic in mind helps avoid surprises. For instance, you edit the dataset at the test level, but accidentally keep the old one at the test plan level, and then outdated values appear in the next execution. On that note, just for the avoidance of doubt, to reuse the exact same dataset across entities, you need to either export then re-import or recreate it. It's time to see this Xray feature in action. Here we have a test issue for cart checkout validations. It's not critical whether you tackle the dataset or the script first. We will begin with the dataset. Based on the admittedly brief issue description and our domain expertise, we will be adding a few seeding and combinatorial parameters. We will start by pulling several of them from the project list, since those variables are common in the e-commerce scope, namely the browser, the payment method, and the product category. Next, we add quantity, total amount, and gift directly to this dataset. For both quantity and total amount, we will stick to the text type of the parameter. This would allow us to have a little bit more freedom when defining the specific values. We will mark browser and payment method as combinatorial, and we will confirm that all their values are relevant for our current scope. And lastly, we will leave the rest four parameters as seeding and determine their scenarios manually. We will try to vary them at least a little bit, but will not focus too much on applying advanced design techniques. And your resulting dataset could look like this. It is important to pay attention to the count preview at the top. The math behind this number 80 is the number of combinatorial interactions, which in our case is 4 times 5 equals 20, and then times the number of seeding rows. So that is 20 times 4, which results in 80. Xray will generate the complete view of all iterations automatically upon execution. Or you can trigger it from the menu for either of the combinatorial parameters here. Now let's save and bring the script up to speed. We already have the static elements in action, data, and expected results, simplified for demo purposes. So the only thing that's missing is the parameterized syntax to tie our script and dataset together. The benefit of doing the dataset first is that we enable autocomplete selection, as you can see here. You can do it by typing the $ and the opening bracket, or it is also available from the drop-down. As a reminder, you can leverage the same parameters in different fields of the step, so you can match the action and the validation or the expected result pretty easily. As we complete this parameterization step, we reread our script and notice that there is one more potential parameter that we actually missed in the initial dataset creation. Here, promotion application is dynamic and dependent on the product category plus gift status. We add the parameter to the script first. And notice a different highlight. As you can see, it is in red. That means the variable is not defined in the dataset. We fix that by going back to our iterations table and appending promotion as a seeding parameter. And the last important task that we will have to do manually here is to select the right value of that promotion parameter based on how product category and gift behave in a given row. Let's imagine that the actual rule is that promotion is only applied when the product category is either A or C and the gift is checked. So in our case, only the first row would match that criterion, which means we set the other three to not applied, and save. We will notice that our promotion parameter turned into the better blue color, which means that it is recognized in the dataset. It is also worth highlighting a couple of dependencies between the script and the dataset. Deleting a parameter from a dataset will not remove it from the test case. It just becomes red and undefined. Changing a parameter name on a dataset will not automatically change its name on the test case and will not create iterations when executing the test, because the parameter would be treated as unknown. As an extra exercise, and let's assume we are moving towards automation and are exploring the cucumber type of tests. With Xray Enterprise, we can leverage test case versioning and choose to copy from our baseline manual one. The benefit is that we don't have to create a separate Jira issue, and we get to carry over the dataset we just created. So now we can just switch the test type to Cucumber and leverage the same parameterized approach. Just note the syntax difference when you're referring to a given parameter. This concludes the Xray portion of the demo. We are set up with our first parameterized test. So far, with Xray's parameterized tests, we've avoided the proliferation of test issues and improved efficiency. This feature has been working well for Xray users, but that doesn't mean we cannot improve it even further. In our example, we had combinatorial parameters browser with 4 values and payment method with 5, along with 4 seeding rows. We got 80 iterations. Imagine we add a new combinatorial parameter with just 2 values. We will get 160 iterations, which is an all-or-nothing kind of situation. Furthermore, what if not all combinations are valid? Manual one-by-one removal of impossible scenarios is not super scalable. That's where Test Case Designer, or TCD, comes in. As a quick summary, it is a specialized, model-based test design optimization tool. The goal is to enhance both the speed and the quality of test case creation, allowing you to find more defects more efficiently. Typically, a user would analyze the requirements in Jira, create the model inside TCD, then move the scripted tests to either Xray or the automation framework for execution. And Xray remains the source of truth for consolidated results. Engage in TCD early in the sprint process with the artifacts like mind maps helps increase coverage and avoid ambiguities up front. However, the tool is pretty versatile connectivity-wise, so different workflows are possible, albeit less common. We will focus on one of those in today's demo. Before diving in, we wanted to highlight 3 key differentiators of Test Case Designer when compared to Xray's parameterized tests. First, advanced rule handling helps you make sure the tests are always valid based on your scope and business logic. Second, Test Case Designer uses an intelligent augmentation algorithm with flexible options, including risk-based, so that you can quickly and programmatically adjust the number of scenarios based on the desired level of thoroughness. And last but not least, insightful visualizations enable you to better communicate ideas and make informed decisions about how much testing is enough. Without further ado, the use case we will be exploring in today's demo is the dataset-only transition between TCD and Xray. We will let the TCD algorithm generate the optimized data table, then export it as CSV without involving scripts, and lastly, import it to an Xray test. Also, a bit of a twist for the starting point. In the past, we showcased building out parameters and values in TCD to kick off your modeling process. There is one more angle: forced interactions import. For the avoidance of doubt, it is optional. You do not have to build the data table in advance. But if you are already practicing parameterization and have assets in Xray or elsewhere, this rather unconventional starting point can accelerate the process. We will use the dataset with all 80 iterations from our earlier Xray example. Just need to format it based on TCD import requirements that you can check in the documentation and this template link. You can see our combinations saved on this screen in TCD, which A. automatically builds out parameters and values on the first screen, and B. informs the algorithm that these scenarios should be included in the data table as the initial rows. As another optional step, but often useful, on the analysis screen, we can check our interaction coverage percentage so far. Moving the slider to match the number of iterations imported from Xray, we can notice that all pairs between browser and payment method are green, as expected, but the rest could be improved since we just created those 4 seed-in rows manually without giving it as much thought as we could have. For this example, we will not keep imported tests. We will instead give the TCD algorithm the freedom to perform fresh generation. But before we do that, let's quickly double-check that our parameter screen is in good shape. We notice all the parameters and values from our Xray dataset are accounted for, but now let's see if we can make a couple of improvements. TCD supports number randomization, so we will convert quantity and total amount to ranged values within the boundaries we defined in Xray. The only rule here is that the ranges cannot overlap. Also, you can mix ranged values with individual numbers. So we will leave that 5,790 as it was. Also, let's imagine that we learned from our business analysts and subject matter experts that crypto and loyalty points are not used nearly as often as the other payment methods, so they don't really deserve separate values. Therefore, we can apply the equivalence class technique and group them under Other. Next, we need to ensure our promotion logic is programmatically handled by the algorithm. To achieve that, on the constraint screen, we will add the following expression. When product category is either A or C and gift parameter has the value checked, then and only then the promotion status will be applied. Note the double-sided arrow highlighting that this is the only way to achieve a certain result. With these two screens completed and optimized, we are ready to regenerate the dataset. We will click on the Scenarios button, and by default, the pairwise option gives us about 23 iterations. The logic is similar to Xray at a high level, but has a few caveats. rather than repeat the combination of browser and payment method for each seeding interaction, TCD treats all parameters as combinatorial and then looks at every pair of them based on our algorithm selection, identifies all unconstrained combinations, and lastly arranges them in as few rows as mathematically feasible. Further, you have more flexibility. Maybe you don't need a thorough test suite, and covering each value once is sufficient, which maps to the one-way setting. Or perhaps you need extra quality and decide that covering every possible triplet is more suitable, which maps to the three-way setting. This provides the variety of middle ground options you can't easily get in Xray. For this example, we will actually select our risk-based approach, and we will set the goal to cover every three-way combination, but only for the parameters involved in the promotion rule. We can quickly regenerate the new dataset based on our preferences, and in this case, it won't lead to the increase in the iteration count. We now have the model inside TCD and the optimized dataset, which we can download directly from the screen and import back to Xray. Now back to Xray, we will open the dataset menu. We could clear out the whole dataset if we wanted to, but at the very least, we need to ensure there are no combinatorial parameters left. Otherwise, you will be doing the double counting. And then from the import menu, we will select the CSV file with the optimized data table we just got from Test Case Designer. There are a few important considerations in this dialog. First, create new parameters, if enabled, will add any non-existent parameters automatically based on the CSV column names. Otherwise, it will just append or update the values for the existing parameters and ignore the rest. Speaking of CSV column names, it is important to keep in mind that if there is an asterisk at the end, then the import process for Xray will treat those parameters as combinatorial and then generate extra iterations you don't need for this flow. So make sure that on the test case designer side, there are no asterisks in the parameter names. And the second checkbox, override existing parameter values, is useful if requirements changed in between the dataset edits. And you can see the exact same table with 23 iterations now attached to our Xray test. And a quick side note, if you are leveraging Cucumber outline format in Xray with the examples table underneath the Gherkin script, you can download the TCD dataset in the pipe delimited format from the same Save As menu and then copy-paste it to the Xray Cucumber test. This concludes the TCD portion of the demo. We now have a faster and more thorough way to generate datasets for any of our scripting needs. We focused on just the design stage in this webinar, but still wanted to provide a glimpse into how Xray would handle parameterized execution. In the test run view, it will automatically create a subsection per dataset iteration. Parameter values will be inserted into the steps, so reading each of them will feel no different from traditional test design. And probably the most important part, you can handle execution details such as status, evidence, or defects at the iteration level. Also, as a brief teaser, we are working on improvements to the built-in test executions report that will tackle iteration summary and details in a more insightful way. In conclusion, data-driven testing can be very useful despite challenges. It is not universally applicable, but especially rule and variation-heavy workflows can reap quite a lot of benefits in both speed and quality. Parameterization is the foundational stage of that technique, so doing it in an optimal and efficient manner is often key. Xray's parameterized tests are a good starting point, then TCD takes it a step further. They cover each other's shortcomings and together help you get the most from parameterization and data-driven testing. As a brief recap of usability in this table, Xray's parameterized tests offer more flexible scripting, while TCD provides more robust dataset generation.
All right, thank you so much, Ivan, for giving us this deep dive into test parameterization. If you want to try Xray and you're not a user yet, you can go ahead and start a free trial through the Atlassian Marketplace. We can share a link with that in a second, and you can also try the test case designer feature from Xray Enterprise. We'll also be sending a link to that as well. So here on this slide, we also have additional resources that will help you get started with test parameterization in Xray. And we'll send a follow-up email in the upcoming days sharing all of these links and resources. So keep an eye out on your inbox for that email. And alongside that, we'll also send a recording of this webinar in case you want to rewatch it or share it with your colleagues. And now let's get right over into our Q&A.
All right, so I'm seeing that we have a number of questions here, Ivan, so let's jump into it.
Sounds good. Happy to answer.
And I'm going to read the first one that's coming from Marta Silva, who is asking, can this parameterization be done in automated tests, or is it only for manual tests?
Good question. All three test types in Xray support parameterization, and then their custom variants as well. And they do it in a very consistent manner. So I think we touched on the manual the most, but Cucumber, the same dataset feature could be applied with just slightly different syntax, and then generic, also the same dataset feature. I think the syntax there is quite close to the manual side. One kind of extra angle of that, though, is that for Cucumber, there's also an option to use the examples table underneath the script instead of the dataset menu function. And the reason why it could be interesting is that the examples table does not suffer from the same limitations. We mentioned that in the dataset menu, you can only have 20 parameters, 1,000 iterations, etc. Examples table could be exempt from that. So if you use Cucumber and you're constantly running in the parameter limit, most likely, then exploring the examples table could be an option. And you can generate it again directly from TCD and just export in that format.
Perfect. Thanks for providing that detailed answer, Ivan. Let's move on. We have a lot of questions coming in. So we have a question from Gregor, who has a bit of a unique use case. So he's asking, we can use a parameter URL of an environment, but then during test execution, this parameter is not clickable. Can you improve that?
I would say we can certainly try. Maybe for those who are not as familiar, there was a slide showcasing how the data table is transitioned to the execution screen, where we can unpack each iteration and put it in a separate section. And so if you had a URL as a value, when you get to that section and you try to click it, it's just text. It's not actually a usable link. And so the request would be to improve that. And I quickly checked. From what I can see, it doesn't look like we have already that particular feature request in our support portal. So the recommendation there would be to utilize that particular option from our support page, submit that request, and then hopefully it gets enough votes to be prioritized highly, and then we can certainly take a look at the implementation. And we will share the link for the support page as well.
Yeah, exactly. You have a specific use case, so if you would be able to submit that ticket, it would great so we can get the visibility and hopefully the traction. Let's move on now. So we have a question relating to the exploratory app, actually. For those of you who might not be familiar, Xray has an Xray exploratory app, and they're asking if the app supports parameterized test cases.
Good question, and thank you for trying the app. As of right now, it does not, but on that particular front, we do have an open suggestion in the support portal. It is relatively high in terms of the priority and how many votes, etc., it has gotten. But as of right now, we don't really have a specific ETA on when it would be tackled, but it is on the radar. One thing that you could consider potentially, this is more broadly for exploratory testing, not necessarily within the app as your first step, is using the generic test types in Xray, or potentially create a variation of that called exploratory, just to be more specific. And then inside the body of those tests, use parameterization just within Xray, and then try to use Xray exploratory app just for evidence gathering, kind of in parallel to the run detail screen inside Xray. It's a little bit cumbersome, but it could get you relatively close to the optimal outcome.
Yeah, thank you for sharing that workaround, Ivan. Let's move on to a question relating again to automation. So Lisa is saying that you mentioned sending the test to an automation tool. Can you provide more details about how that would work?
Sure. It is dependent on the tool, and it is dependent on what you want. So there are generally two processes. One is more for Cucumber. The other one is more for everything else. So the one that for everything else is actually a little bit easier. This is where you just download the data table. Either you made it previously in Xray for a manual test and now you want to automate that, or you made it directly in TCD, doesn't really matter. But you get that data table, and then if your automation framework is a little bit more script-based, then you need to have a module that does CSV import, well, CSV or similar, import and parsing, and then your script just needs to be geared towards iterative data-driven execution. It's not a big change to the code, but it does take a little bit to adjust. And then if your automation framework is a little bit more no-code, low-code, so for instance, Renorex Studio just has a UI option where you import the data source in a given format and then connect that data source to the recording. That would be another option. Again, you just take that data source from either Xray or TCD rather than creating it manually. But that's kind of the primary thing. And then once you do the execution in that flow and import the results back, Xray will automatically create generic tests for you. And then for the Cucumber flow, it does get a little bit more complicated potentially. We do have a dedicated tutorial for that, but there, at a high level, the key decision is whether you want to manage your Cucumber files in Xray or in a source-based or source control system. And depending on that, either you are exporting feature files from Xray or you're potentially importing them to Xray from the source control before passing them by API to the automation tool. I know this is a little bit brief, but we do have a fairly detailed explanation in that particular tutorial. We can just include the link in the follow-up. And then if anything else comes up from that, just let us know.
Exactly, yes. In the upcoming days, we'll be sending a follow-up with all of the links that Ivan is mentioning here, especially to this tutorial. So just keep an eye out and you'll be able to check that out. So let's move on to a bit more of a use case from Jay Connors. So he's saying we use Xray to develop tests manually that are then moved to dev to implement via Newman for API integration testing. How might this work using Xray and Test Case Designer?
Good question. Ideally, would like to know a little bit more about what the manual development of tests in Xray involves, like what exactly is in the test content of those, because it is kind of related to one of the previous questions. Typically, what we see clients do for API tests is that they are developed elsewhere, and then the data table is attached to them in that framework. And once the runs are completed, then the results report is imported to Xray, and then Xray automatically creates generic tests to match the results. And part of the reason why is that there is not a lot of support, unless you do Cucumber, there's not a lot of support for writing automated tests in Xray as of right now, as compared to classic IDEs like Eclipse, for example. And so if you do them manually in Xray and then you have to move them outside, typically that would be a bulk export of feature files, I'm assuming, because you need to carry over the ID from Xray. And then that export would also potentially need to grab the data set and pass both components to Postman. Still run the tests, still import the results. So that part doesn't change. It's just a question of, do you really need to develop them manually in Xray? If yes, there would have to be an export of both the tests and or the data set, depending on how that's structured. And if the answer is not really, then you're just transitioning to developing tests outside, getting the data set to that place, running them there, and then just importing the results. So this might be another one where a support ticket could be helpful, just so that we can probe a little bit more into the specific reasons for the manual development on the first step.
Sounds good. Thank you for looking at that use case, Ivan. Let's move on to a question from Raj Kumar. He's asking how to connect the database from Xray. For example, I want to execute my SQL Server unit test cases from Xray.
Okay, so the key point there is from. And as of right now, the only way you can trigger something from inside Xray is, and this is also related to a couple of other questions, is if you have Xray Enterprise. Now, the difference between Xray or Xray Standard and Xray Enterprise is that Xray Enterprise builds on top and adds a couple of features. One is Test Case Designer, which we discussed. So you can only access it if you have Xray Enterprise. Doesn't matter whether it's cloud or DC, but it has to be Enterprise. And another feature that it adds is called Remote Jobs Trigger. What that feature allows you to do is have an extra option on your test plan or test execution issue where you set up the pipeline integration and you trigger it by clicking that option in Xray. And then the pipeline runs. We don't really have any specific control or visibility in terms of what that pipeline actually does. So however you structure it, it would work. And then, well, in the optimal flow, at the end of that pipeline run, there's an import step again back to Xray. So for SQL Server specifically, there's no direct connection as part of Remote Jobs Trigger. We are more focused in that particular feature on CI/CD tools like Jenkins, GitHub, GitLab, and I believe Azure. So if you wanted to get to SQL Server, then you would have to use that feature, have a CI/CD tool, and then the CI/CD tool has a task to get to SQL Server. That would probably be the closest you can get. But again, for most of these relatively specific execution or implementation use cases, a support ticket for a closer look could get you a more accurate advice.
Yes, exactly. Reaching out to support would be the best case in this specific example. Let's move on. So we already kind of answered the question, the difference between Xray test management and Xray Enterprise. So as Ivan mentioned, Xray Enterprise builds on top of Xray. It has additional features like the test case designer, but you also have additional features on there, for example, test case versioning. You're also able to trigger automated tests directly from Xray, dynamic test plans, and you also have 24/7 support. So it's really for companies that are looking for an experience where our support is really there with you. So let's move on to some more specific questions that are coming through. One relating to where Xray data is stored. This is a GDPR question. Ivan, if you want to take a look at that.
Yep. I think one of the important things you need to keep in mind is that somewhat recently we made the data residency options available for cloud as part of also the Atlassian initiative for data residency. And so you do have a choice where the data is stored. So if you are in Europe, I believe we offer Europe more broadly and then Germany as a separate location. So you would just need to make sure that that is the option for your Jira data as well as then Xray data. And if you were a user before the data residency became available, then you would just need to make sure that you schedule the migration for that. It does take a couple of preparation steps, but you can move the data wherever you would prefer. And then obviously data center deployment is your host.
Exactly. We have just another generic question, not relating to test parameterization, but more to automation. If Xray integrates with other tools such as GitHub, Jenkins, Selenium, or any CI/CD pipelines.
Right. So that remote jobs trigger we mentioned, there is a selection of, I believe, 6 pipelines as of right now. And it does include Jenkins, it does include GitLab, and it does include a couple of other things. And then for any of those that we maybe don't support on the remote jobs trigger front, the general execution flow is that you focus on creating an execution report in one of the formats that we can parse and support. So for instance, JUnit, NUnit, XUnit, JSON in some cases as well. So we care a little bit more about that format than we do about how exactly you run the tests. And then you can import that results report by API to create tests automatically. So if a very specific framework and or format report that you really like is not supported, that would again be something to submit the ticket about and see if there are other users who would be voting for it.
Exactly. Another question relating to the test case designer from Emin asking, can we migrate test case management to the test to DCD?
That's a good question. I would say fully migrate, no. Just because test case designer is a very specialized tool. It does one job, it does it pretty well, but it doesn't expand into other stages of test case management that you probably would want, such as executions tracking, reports consolidation, like visualizations and reporting on top of your results, as well as maybe I should have started with that, linking tests to your requirements in Jira, right? So it doesn't necessarily step on Xray's toes in those areas of test management. It just focuses on optimizing that kind of middle part where you know what you want to test. Now, how can we create the thorough test suite for that particular goal? So we would not recommend replacing. You would find a lot of features just not there intentionally. So using two tools side by side is the recommended approach.
Exactly. And just to follow up on that, Test Case Designer is really a complementary feature to test case management in general, and it's really about optimizing test case design. So not a test case management tool. Let's see, any other questions that we have coming through? People are asking about the links to some of these examples that we've talked about in the documentation. We will be sending those, as I mentioned, and we will also be sending a recording of this webinar in the follow-up email. So keep an eye out for that. And I believe that's all the questions we have for today, Ivan.
Maybe just one more. I think there was a question about connection between TCD and test plan and how you would link both.
Yes, I missed it.
It's again an interesting one that might require a bit further probing and investigation to see the exact use case. But first, you can import the data set from Test Case Designer to the test plan level in Xray. Again, from the connectivity standpoint, there is no limitation or preference in terms of whether you do it for the test level or the test plan level or even test execution level. It is up to you. Now, again, if you had already a data set at the test plan level and you want to optimize it, you can export it from there, pass it to Test Case Designer. Now, in terms of the exact, like trying to connect multiple tests from a plan and build a model based on them, it is feasible. It's just fairly manual. Like you would just need to read through the tests in a given test plan first in Xray, figure out what are the elements that would allow you to build a model, do it in Test Case Designer, then export it back. Not sure whether you would actually do it in just the dataset format or the scripted one. That could also be an option. But you can kind of connect the two together. It's just dependent on your specific goal of why you would want to do that. The steps to perform are a little bit different. So we would recommend, again, another support ticket to take a closer look. Maybe if you could share a few more details about the use case, that would be great.
Exactly. And we have just a follow-up question to that. Can we extract the list of parameters from my written test cases to be used in the Test Case Designer to recheck the coverage?
If they were in a dataset format, very easy. Just export from Xray, upload to TCD. If they were more like inline parameters, so for instance, you just had, let's say, 3 manual tests, and then in the data column, you had stuff like amount equals X, and the next test case amount equals Y, etc. Then collecting all of them in one CSV would take a little bit of effort. But once you do, you can. But as of right now, we don't have a way to process or parse like texts in terms of exporting just the steps and figuring out where the parameters and values are in them. We do have an upcoming AI initiative for Test Case Designer where we would do exactly that, and you would be able to just submit a text file with your test cases, and the AI will try to figure out what are the parameters and values there and how we can optimize that, but not quite there yet.
Thank you so much, Ivan, for giving all of these detailed questions and a little preview there. As we mentioned earlier, we'll be sending a recording of this webinar to everyone who registered and attended. So just keep an eye out for that. Thank you everyone who joined us today. We hope you found this presentation interesting, this deep dive into parameterized tests. We hope you take advantage of this feature in Xray and also try out the test case designer with an Xray Enterprise. As we mentioned before, you can start a free trial in the Atlassian Marketplace. Just search for Xray Enterprise and you'll be able to start your 30-day free trial. And keep an eye out on your inbox for the follow-up email with all of the documentation and links we talked about today. Thanks again, everyone, and we'll see you in our next webinar.